Well guys, AFERY did it again. They released a brand new power station with very impressive features and an amazing price. So let's take a closer look. So this is the AFERY P280. The internal battery is a lithium iron phosphate rated at 2048 watt hours of capacity. Now the power station gets its name from the 2800 watt pure sine wave inverter, and I love that it has the RV outlet built in for connecting larger loads. Now this model is packed with 6 USB ports for charging your mobile devices, including 2 super fast 140 watt power delivery ports. Now they've also provided multiple 12 volt output options. You have a 10 amp cigarette port, you have 2 3 amp 5521 barrel ports, and then you have an XT60 which is rated for 25 amps or over 300 watts of 12 volt output. That is awesome. Now when it comes to charging the P280, this does have dual solar charge controllers. They're rated for 600 watts each or a combined 1200 watts. Now this also supports fast AC wall charging with up to 1800 watts input, and you can also adjust the AC charging speed using the Smart app. Now as for UPS functionality, this has a super fast UPS cutover time, advertised to be 10 milliseconds or less. Now AFERY is super competitive on their pricing, and with this model it's no different. They have this on sale for $649 right now for Black Friday, or 31 cents per watt hour. That is a crazy price for 2048 watt hours of capacity. Now speaking of Black Friday, AFERY does have a Black Friday sale going on right now, and these are typically the lowest prices throughout the year. For example, if we scroll down here, we have the P310, which I reviewed earlier this year. It has a massive battery, it's great for home backup, 3,840 watt hours of capacity. Yet look at the price, $933. or 24 cents per watt hour. That is an amazing price. And then next to that you have the P210. This is kind of a lesser featured version of the P280. They have the same battery size, but this has a smaller inverter. It's priced at $559 or 27 cents per watt hour. So these are crazy prices. So now you guys understand why I wanted to test this power station on the channel. It has a very good price and it has a really good set of features. And just like earlier this year, I tested the P310 and was very surprised by the performance. Does this one perform in the same way? So in the rest of the video, I'll be doing extensive testing on the power station. My goal is to find out how this actually performs. And then hopefully after putting it through all the tests, you guys will be educated to know if you want to buy this power station or not. So let's find out how the P280 actually performs. In my first inverter test, I wanted to see if the power station could run the maximum advertised load of 2800 watts for 15 minutes without shutting down. Now during this test, my oscilloscope was showing a pure sine wave output, but I did notice a bit of distortion and slight voltage drop while running the maximum load. Taking a closer look, you can see I measured 117 volts at 60 hertz. Now after 10 minutes of running the maximum load, the cooling fans produced about 57 decibels from 3 feet away, so they do make a bit of noise when running at full speed. I then used my thermal camera to confirm the power station temperatures during the test. I saw a peak of only 106 degrees Fahrenheit, so even though the fans are a bit loud, they do an excellent job cooling down the power station. The P280 passed the test and was able to run the full rated load for 15 minutes without shutting down. Now what about the maximum wattage the inverter allows you to pull before it actually overloads? As I connected up more loads to the inverter, instead of allowing higher wattage, the power station started dropping the inverter voltage down. As I connected over 4,000 watts of heaters to the power station, you can see that the inverter voltage dropped as low as 91 volts. So once the load goes over 2,800 watts, you'll start to see the inverter voltage drop by design. Now I wish this setting could be enabled or disabled in the Smart app, since low voltage like this can damage some electronics. To avoid voltage drop like this, don't pull over 2,800 watts on the inverter. Okay, so moving on to the next AC inverter test, I want to see how well it handles surge or inductive loads. Now because this is a medium-sized power station, we're just going to skip the air compressor and start with the 12 amp vacuum. If it powers up that, then we'll move on to the 15 amp table saw. And if there's no issues there, we'll try the vacuum and the table saw at the same time. Now in order to measure the inrush current, I have my clamp meter on the hot wire. It is going to be set to inrush mode. So let's see if it can power up the vacuum. Powering up the vacuum in 3, 2, 1. So it pulled about 29.96 amps. It did have a slight delay on startup, but it did power up the vacuum. Next, let's go ahead and try the 15 amp table saw in 3, 2, 1. Okay, so you could hear there was quite a bit of voltage drop as that turned on, but it did power up the table saw. You can see 28.29 amps, so it's actually just a little bit less power because I think we got more voltage drop during that. But let's see if it'll do both at the same time. So I plugged in the table saw and the vacuum, so let's test that out in 3, 2, 1. Okay, you could hear quite a delay there and a lot of voltage drop, but it did power up the vacuum and the table saw at the same time. We pulled a little bit more amperage, 30.75 amps. So it's probably not super good for the inverter to power up these larger loads, at least both at the same time, but it did seem to do well on the vacuum and the table saw on their own. So in my next test on the inverter, I want to use this outlet tester here to see if the output has a floating ground or a bonded ground. So with the inverter turned on, you can see it does have a floating ground. Now just to confirm, we are getting the same results from the 30 amp output. Now I've just connected the AC charging cable, so let's see if anything changes. So now the power station shows grounded, which means it does pick up ground from the charging source. And it looks like we get the same results on the 30 amp port. Now for our next test on the AC inverter, I want to see how fast the UPS cutover is on the AFERY P280. Now they advertise it to be 10 milliseconds. So to test that out, I have my desktop workstation and monitor connected into the power station, along with my studio lights, and it is charging from the wall right now. So as power is disconnected, it will swap over to battery backup, and to track to see how fast that is, I have my oscilloscope also connected to the AC inverter. So let's go ahead and do our first UPS test. I have the recording setting enabled on the oscilloscope, so I'm hoping to catch the actual cutover. So 3, 2, 1. Okay, so we were able to catch the actual cutover. So this is when it was being powered by the wall, then the power cut out between these two cursors, and then this is inverter power. And you can see the distance between these two cursors is 8 milliseconds. So it does perform just like advertised. Remember, it was advertised to be under 10 milliseconds. And the good news is the computer is still running after that first cutover. So let's go ahead and test a couple more times. So let's go ahead and move forward with the second UPS test in 3, 2, 1. Third and final UPS test in 3, 2, 1. Okay, so just a quick flicker of the lights on that one, but through all three tests, the computer stayed powered on. Now moving on to the next test, how much usable capacity should you expect when running loads off the inverter? I discharged the power station with a resistive load until the battery died and measured 1880 watt hours of usable capacity. This result was actually 91.7% of the advertised capacity, which is above average, especially for a budget unit. I also completed an additional capacity test with the AFERY expansion battery connected for a total of 4,096 watt hours. When the power station inverter shut off, I measured 3,780 watt hours, or about 92.2% of the rated capacity, so a slightly higher efficiency with the added expansion battery and double the runtime. Now, how much power is used as the AC inverter is turned on for a long period of time? Starting with the power station fully charged and leaving the inverter turned on for 12 hours, the state of charge dropped down to 92%, meaning that the inverter used 8% of the battery over 12 hours, or about 0.66% per hour. That's a great result for this test. Next, does the inverter produce any interference? I measured over 2,000 millivolts of EMI using my dirty electricity meter, but is that EMI actually audible? Connecting my guitar amp to the inverter, I did notice a very slight pulsing noise when connected. Can you hear it? It's not very loud. And finally, for my last AC inverter test, I wanted to see how long it could keep my basement refrigerator running during an outage. So after 28 hours of it connected up to the power station, the inverter finally shut off and the fridge powered down. That's an impressive runtime for a medium-sized power station. Okay, so we finished the testing on the AC inverter. So we saw good things and we saw some bad things. Let's just talk about the performance. So starting with the negative things first, the fan noise when you're running max load breaks the threshold of 55 decibels. We saw 57 decibels, so the fans are a bit loud. The good thing to that is that they're moving a lot of air and it keeps the internals of the power station cool. Also, we saw a slight bit of noise on the AC inverter with the guitar amp test. It was just kind of this pulsing. It was kind of hard to hear, but I think that you still might hear that if you had this plugged into some sort of sound system or speaker setup. Now, as for the inverter output, we saw a pure sine wave output. It surged well. It had very good idle power consumption at only 0.66%. And then also, as we were doing the capacity test on the AC inverter, we got 91.7%, or almost 1900 watt hours of the rated capacity. So very good capacity on the power station. And finally, the UPS test was under 10 milliseconds at 8 milliseconds. So overall, for a budget power station, there are some things that aren't perfect, but it actually has pretty decent performance. Okay, so moving on to the next portion of the video, we'll be testing the DC output on the power station. Now, I love to see multiple options for 12 volt output. On this model, we have a 12 volt cigarette port, two 5521 barrel ports, and then finally, we have an XT60 good for 25 amps. Now, you also have a bunch of USB ports for charging your mobile devices. You have two 140 watt power delivery ports, you have two 20 watt power delivery ports, and then you have two standard USB-A ports. Let's go ahead and move forward with testing the 12 volt output first. I have my load tester powered on and connected up, and we are getting a regulated 13.65 volts. Now let's see how much power we can get from the 12 volt socket. It's rated for 10 amps. I have a 10 amp load running for 132 to 133 watts. Let's jump it up to 12 amps to see if it can handle that. Okay, so 12 amps, or right under 160 watts. Let's see if it'll do 13 amps. Okay, so 13 amps overloaded the output and it did shut off. Next, what about the 5521 barrel ports? They're rated for 3 amps each. Let's just go ahead and start a 5 amp load. So with 5 amps, we're pulling 66 watts, 67 watts. Let's try 6 amps. So stepping it up a little bit, right around 80 watts. Let's try 7 amps. Okay, so 7 amps did overload the 5521 port. And finally, what about the XT60, which is good for 25 amps? I love that this has a high DC output. We are running 25 amps from the power station, or about 338 to 37 watts. Let's see what happens if we step it up to 26 amps. So let's go ahead and do that. Okay, we just see a little bit of voltage drop here. We're getting around the same amount of power. It's typical when you're pulling a high level of amperage, it'll drop down the voltage. Let's see if it'll do 27 amps. Okay, there we go. So if you hit 27 amps, it will overload the output. So you're good for about 340 watts before it shuts down. Next, let's go ahead and test the USB ports, starting with the first 140 watt power delivery port. We are seeing power delivery 3.0 at 140 watts, or 28 volts and 5 amps. Plugging into the second 140 watt port, we are seeing these same results, power delivery 3.0 at 140 watts. I love that this has two 140 watt ports. Connecting to the 20 watt port, we are seeing power delivery 3.0 at 20 watts, and we are getting the same results on the second 20 watt port. And finally, connecting to the USB-A ports, we are seeing dedicated charging protocol at 5 volts and 2 amps, or right around 10 watts. And we are seeing the same results on the second USB-A port. Now, what about using the USB ports and the 12 volt socket at the same time? I have all the USB ports connected up right now. We're pulling about 280 watts. You can see it's jumping around a little bit. Let's try a 12 volt load. We're going to start with a 20 amp load. So let's turn this on. Okay, so 20 amps going out of the DC output. We're pulling over 550 watts. This is jumping around a little bit. Let's try 21 amps. And we're going to slowly try to get up to 25 amps. So we're at 570. Let's try 22 amps. Okay, so 22 amps overloads the DC output when you have the USB ports maxed out. So you can expect slightly under 600 watts before it overloads if you're using the DC output and USB ports at the same time. That is a massive amount of power. Next, how much usable capacity can we expect from the DC output? Using my electronic load to discharge the power station, I measured a total of 1,831 watt hours as it turned off. these results were 89.4% of the advertised capacity, above my goal of 85%. Now, how much idle background power is used if you leave the DC output turned on? I started with the power station fully charged, and checking in 12 hours later, the state of charge dropped down to only 97%. So the high DC output is quite efficient sitting idle. So we just finished testing the DC output on the power station, and I love any power station that has the high DC output. And this one with the XT60 rated for 25 amps, we got 340 watts continuous from that port. So powering multiple 12-volt loads like a 12-volt refrigerator, diesel heater, 12-volt fans, lights. Basically, if you wanted to use that port to power multiple loads at the same time, that is totally fine. Now, we did a capacity test on the power station. We actually got pretty good results as well at 89.4% of the rated capacity. It was around 1,830 watt hours, which is excellent for a budget power station. And even when you have the DC output turned on for a long period of time, the idle power usage was about 0.25% per hour. So very efficient as it sits idle. Now, the other thing that I like about the power station, and not many companies are doing this, but I love that this has 2 of the 140 watt power delivery ports. So the USB ports are modern on this power station. Well, now we're moving on to the next section of the video where I'll be doing charging demos on the power station. Now, AFERY does provide this zipped bag for both of the charging cables. Now, on the inside, you have 2 different cables. You have the solar charging cable, which has an XT90 and MC4 connections, and then you have your AC wall charging cable. Now, I've rotated the power station so you guys can see the left-hand side where you have both of the charging ports under this flap. Now, taking a closer look at the specifications for each charging port, on the left you have the AC charging port. This supports 1800 watts or 15 amps input. Now, on the right you have the DC charging ports. You actually have 2 of them. They are XT90s, each one's good for 600 watts or a combined 1200 watts. Now, if we look at these, I really like XT90s. They support a higher amount of amperage without overheating, but you'll notice that this is limited to 55 volts input. So instead of 60 volts, it's only limited to 55. So we will have to be careful on our charging input here to make sure that we don't go over 55 volts or it will damage the power station. Now, I've connected the AC charging cable, so let's go ahead and do a demo of the charging speeds. In the Smart app, you can select multiple charging speeds. For example, selecting 300 watts actually gives you 600 watts input on the power station. Let's go ahead and select 600 watts and see what happens to the charging speed. It looks like it's about 300 watts off. So 300 watts equals 600 watts, 600 watts equals 900 watts. Let's go to 900 watts within the Smart app. Once again, it just takes a second to load, and we'll see it jump up to about 1200 watts. So that means 1200 watts is going to give us 1500 watts. Let's select that in the Smart app. So jumped up to 1500 watts. And as we select 1500 watts, we should be pretty close to 1800 watts. I'll definitely let them know to update this in the Smart app. So basically, instead of 300 to 1500, it should give you 600 to 1800 watts. And you can see that we are right on par there, almost 1800 watts charging input. It's very nice that it does have the adjustable charging. It's just a little bit different than what you actually get in the Smart app. Now let's go ahead and move forward with some DC testing on the power station. I have my 1200 watt adjustable power supply connected into the XT90 port. Now remember, each one of these ports is good for 600 watts. I've adjusted the output to simulate a 12 volt battery, so connected up to 13.5 volts, we are seeing 100 watts. The power station is limiting the input to 8 amps, even though I have my adjustable power supply set to 25 amps. So charging with the 12 volt battery, you're going to see around 100 watts input. Now I've adjusted the output of my power supply to 26 volts to simulate a 24 volt battery. So we've jumped up quite a bit in power. We are now getting 522 watts, and the amperage has jumped up to 20 amps. So as you get above 20 volts or so, you will see the higher amperage input. So 500 watts input by connecting up to a 24 volt battery. That's awesome. Now, what if you had a couple residential solar panels that you wanted to connect up to the power station? Well, I have the voltage set to 33 volts on my adjustable power supply. We are seeing 18 amps input because that is getting the full 600 watts. Remember, my power supply is set to 25 amps. So if you had two 300 to 400 watt solar panels connected together in parallel with around 33 volts, you could max out one of the charge controllers at 600 watts. Now, one other example here, I've raised the voltage to 40 volts. So whether you want to put multiple 12-volt solar panels in series or just use a larger format solar panel, you could easily max out the charge controller at 600 watts with 40 volts and about 15 amps. Now, if you remember, each one of the charge controllers is good for up to 55 volts. So how close can we get before it shuts off? So we are currently at 52.9 or 53 volts. Let's try 54 volts and see what happens. Okay, so 53.9 volts, we are still charging. Let's try 55 volts. Okay, so once you get to 55 volts, it does shut off the charging input. Now in my next test, I want to see if my adjustable power supply can connect to both the ports at the same time to charge at 1200 watts. Some power stations allow charging from the same source on the solar input ports, so let's see if this power station supports that. So I have my adjustable power supply set to 48 volts and 25 amps, and it's connected up to both of the ports, so let's turn this on. And we'll see what happens. We do see power input on the screen. See if it thinks a little bit longer here. Okay, so we saw a brief 1200 watts input. And then it shut off. So it looks like it does not like having the same charging source on both of these ports. So if you want to charge with 1200 watts, you are going to have to connect up independent solar panels or independent batteries to each of these ports. In my next test, I want to see if this supports dual charging, or AC input and DC input at the same time. Now, if you look at the screen there, we are seeing it jump over 2100 watts. I have this set to the fastest AC charging speed, which is around 1800 watts, meaning that we're getting around 400 watts from DC input and 1800 watts from AC input. So it is allowing dual charging. Now, I've been letting the power station dual charge for a bit now, and you can see the wattage is still jumping around. We've seen a little bit over 2100 watts, and then it goes down to 1800 watts sometimes. And you can see that the DC input is also fluctuating. So kind of interesting that the wattage is jumping around a bit. It is allowing both inputs at the same time, but it's just not super steady. Next, I want to test pass-through charging. So I have the USB ports, the DC output, and the AC inverter all enabled while charging from grid power. So you can see we have a total input of 1800 watts, and then we are running a total of 468 watts through our loads. So a portion of this is going to charge the battery and then run the loads. But what happens if we turn on a large load? Will it shut off the inverter? Will it stop charging? Let's find out. So right now this 500 watt heater is enabled. Let's turn on this heater to see what happens. So I'm going to step this up to 1500 watts. We should see some interesting numbers here. Okay, we are pulling 2300 watts. It is dropping a little bit. I'm guessing that this is going to overload here in a minute because it's meant to pull 1800 watts and we're going over that. We're pulling 2000 watts right now. We'll give it a couple seconds here. There it goes. Okay, it shut off the AC inverter. So if you happen to pull too much power, it will shut off the AC inverter, but it still continues to charge. Now, I failed to mention that during that test, the USB ports and the DC output remained on. So if you are doing pass-through charging and you happen to pull over 1800 watts, you do have just a window of leeway and then the AC inverter will shut off, but the DC output and USB ports remain on. Next, I also wanted to test the AC charging efficiency, or how much energy it takes to fully charge the battery using AC input. Starting from empty, I tracked the usage with an inline watt meter, and I measured 2330 watt hours to charge the 2048 watt hour battery, which means the AC charging process is about 87.8% efficient. Okay, so let's go ahead and do some solar testing on the P280. Now, if you'll remember, there are dual solar charge controllers. Each one's good for 600 watts or 1200 watts combined. Now, our target voltage and amperage is going to be at least 30 volts and 20 amps. That'll give us 600 watts on each port. Now, you can swap those numbers around a bit, but that's what we're aiming for. So what I have right here for one of the solar charge controllers are these Zoop W 350 watt panels. We are going to put these together in parallel. We are over paneling slightly with 700 watts, but that should help us get 600 watts on one port. Now moving on to the next set of panels that we're going to be testing. These are the Renogy 200 watt shadow flux panels. Basically I have these three wired together in parallel. That is also going to give us right around 30 volts and 20 amps. So I'm hoping to be able to get pretty close to the full 1200 watt input. Now as for the solar conditions, it is a late fall day, almost winter. We have a bit of high clouds and haze, so we'll see how much power we can actually get in on the power station. Okay, so I just connected both of the Zoop W 350 panels into one of the charging ports. We are getting right around 530 watts. So with those clouds in the way and the really low angle of the sun, this is about what I expected with these solar panels. For example, if we look at the Zoop W solar panels, they have some pretty short kickstands. So in the middle of the summer, this is great to have this sort of angle, but as you get closer to winter solstice and the sun is lower in the sky, having a vertical solar array like this, you actually get pretty decent power. Okay, so I disconnected the Zoop W solar panels, and now I've plugged in the shadow flux panels. Now remember, this is 600 watts of solar, so plugged in, we are seeing about 517 watts in on the power station. So now we can plug both of them in and see how much power we get. Okay, so now I have both of the solar arrays plugged into the power station. I've been letting it charge for about 5 minutes here, and it's good to see that it does support connecting two different arrays at the same time. So we have different voltages and different amperages in each one of these arrays. They're connected to their own charge controllers, and they do work independently, so that's really good to see. Now, if you look at the screen here, I have seen a peak of about 1020 watts. You can see it's jumping around a bit. I did see this when I was testing with my adjustable power supply as well. We've seen as low as 930 all the way up to over 1015 watts, but it is charging with both of the solar arrays. This is going to charge the power station fairly quickly because we are pretty close to the full 1200 watts input. I'm guessing if we had perfect conditions today, we'd get even closer. Now, because this is a smaller, lightweight power station, I wanted to demonstrate using these smaller portable panels or even small format 200 watt panels. But if you're looking for more of a permanent setup that's more affordable, of course you can use these larger format residential 400 watt panels. Now this is only 3 of them, but you could have 4 of them. What you'd do is you'd connect 2 of them together in parallel on one of the charging ports, and then you could have another 2 for the second charging port. Remember, your target voltage and amperage is 30 volts and 20 amps, and if you're able to do that, you can max out the power station. Okay, so the power station's been charging for a bit, so I wanted to check in on it and take a look at this. It's at 92% state of charge, and we are seeing 500 watts input instead of 1000. Now, I've seen some power stations do this as they get closer to 100% state of charge. They do slow down the charging input. So it looks like once you hit 90% state of charge and above, it will slow down the charging to 500 watts. We still have both of the solar arrays plugged in with 1000 watts of power, but the power station is limiting it to 500 watts. I also tested having solar panels connected overnight on the P280 just to make sure there weren't any issues. In the morning, once the sun started coming up, the power station started charging, so it's okay to have solar panels connected all the time. I also tested having the power station completely turned off and then connecting solar input. The power station turned on and started charging, so solar panels do wake up the power station if it's died or if it's been turned off. So I just want to clarify 2 things that I learned during the charging test on the power station. The first one was when you're using the smart app to adjust the charging speed, the AC charging speed. We had a discrepancy on the charging speed of the app versus what we saw on the screen. Now, I reached out to AFERY support and they did say they're working on a firmware update to fix that issue, so it should be fixed in the future. And the second thing is kind of my complaint with the solar charge controllers having a 55 volt limit. Now, we all love power stations that have over a 60 volt limit, but the 60 volt limit is kind of getting more common. And I would say the 55 volt limit on this one is just kind of it's just kind of a complaint. Now, don't get me wrong, I absolutely love that the solar charge controllers use XT90. That's excellent for allowing a lot of amperage without overheating, and also each of the ports allow 20 amps input. So you can basically have 40 amps of solar going into this to get you the full 1200 watts, It's just kind of a bummer they didn't give us the extra 5 volts there. So 55 volts is the limit. You go above that, it's going to stop charging or possibly damage the power station. So you want to make sure you plan for your solar panels to have less than 55 volts open circuit when you are connecting them to the power station. So let's go ahead and do a brief demo of the Smart App. I already have the device set up in the Smart App and it's bound and it's on my Wi-Fi. So if we select that, it just takes a second to load the actual device. So we'll just wait for that. So once you're in the Smart App, you have the state of charge and then you can see what outputs are enabled. So you can see I have the USB ports turned off, the AC inverter turned on, and the DC output turned on. So you can toggle these on and off from the Smart App. For example, I just turned on the USB ports. At the bottom, you actually have a light that you can turn on. It has multiple modes. It's kind of got a yellowish tint to it, but it is nice that you can control the light from the Smart App. So you just got a basic screen here. Now you do have the ability to go into the settings. There are a few settings here. So device icon, device name, permission management. Those are just basic settings. You have the key sound, which is like a beep you can disable. I have that turned off. You have the remote shutdown, which is the ability to kind of turn the power station off remotely. Just be aware you can't turn it back on unless you're in person and you push the power button on the power station. Under energy management, you have the ability to set the lower discharge limit and the upper charging limit for UPS mode. And then you can go into the charging settings. I already went through the AC charging on the power station, but you have a few other options. So you have AC silent charging you can enable. AC booking charging is actually a way to schedule when you want charging to start, which is kind of cool. And then you can also adjust different charging modes for DC input. There's PV mode or there's PV mode compatible with car charging, and that just automatically sets the 12-volt charging input. And you can also set the current input for DC charging, which is kind of cool. I'm just going to have that set to the maximum input so I can always try to get the maximum amount out of DC charging. Now going back to the settings menu here, you can see we have screen shutdown time. This is kind of the idle screen time you can set. If you don't touch the power station, this is when it's going to turn off the screen. And then below that, you have standby times. These are kind of like the auto off settings. So if you're not using the AC inverter and it's enabled and like it doesn't sense a load, when is it going to turn off? If you have the DC output turned on and there's no load, when is it going to turn off? And you have the ability to set certain times here. I like it to always just stay on, so that's what I have set in the app. Now, moving to the bottom, you do have the ability to set the network configuration, so Wi-Fi settings. You also have the ability to check the firmware version and update the firmware, and then you can see the fault log or types of errors that you've seen on the power station, like if you've overloaded the AC inverter or if you've pulled too much power on the DC output, it'll show logs in there. So after completing all the testing on the AFERY P280, I think the performance is pretty decent, especially for the price. You gotta remember, this is a budget power station. It has its quirks. It's definitely not perfect, but since the price is so affordable, I think it's still worth it. You guys will have to let me know what you think about the power station performance down in the comment section. Now, the power station does come in at 47 pounds or about 21.6 kilograms. Now, AFERY does offer a 7-year warranty on the power station that's a little bit longer than this industry standard, which is good. But AFERY's been around for a couple years. They don't have a huge track record on their support yet. So if you have purchased an AFERY power station and you've had to deal with their support group, let me know what your experience has been down below. Did they replace the power station? Was there any sort of refund? I'd like to know what the quality is with their support group and if they've handled any issues that you guys have seen. Okay, so let's go ahead and see how this did in my power station grading system. You're gonna see the results up on the screen. So it missed out on 2 items. First, there was slight noise on the inverter, and also the fan noise was above 55 decibels, but it passed everything else really well. So it got a final score of 9 out of 10 points, or an A- grade, which is really good for a budget power station. Okay, so we're coming to the end of the review video. We've completely tested the P280. We put it through my power station grading system when we have the results. So now, after all that information, I'm curious what you guys think about the P280. Is it a power station you'd buy, or would you choose something else? Make sure you leave your feedback in a comment down below. Now, anybody that's interested in learning more about the power station or picking it up during the Black Friday sales event, I will have the links to this down in the video description, along with AFERY's P310 and P210. There are other power stations that are currently available. Now, a special thanks to AFERY for sending out the power station for this testing and review video. My goal is to make an unbiased video that focuses on the actual performance of the power station. So if you guys think I did a good job doing that, please smash the thumbs up button on your way out. I will recommend a couple of the videos. Make sure you check out the performance on the AFERY P310, the larger power station compared to this one. Thanks for watching. We'll see you guys in the next one.